Welcome to the Fourth Industrial Revolution. Today I would like to speak about how we are at the edge of something that's going to change our life forever. Same way that, as you will see, the previous industrial revolution did change our way of living. My name is William Pagnon from Freelance Robotics. Our company provides custom services for manufacturing, product development, as well as some commercial products that we have selected and are distributor for. We provide um, a lot of engineering services such as PCB board, CAD development, mechanics, electronics, artificial intelligence, software development. We know over 20 programming language and are in the robotics field for a little while now. So, what is the fourth industrial revolution? Well, one simple word to sum up what it is connectivity. And that's, as you would have heard before, IoT, Internet of Things, Industrial Internet of Things, IIoT. Those terms basically show that we have reached a maturity of Internet where people are connected together through computers from one end of the world to the other without any lag or time delay that are noticeable. This is the first part of it, is that it is a human connectivity as well as you have interaction between fields, between companies, between expertise, which provide to the Industrial Revolution another dimension where you get all the fields merging into a combination of fields. It's a bit like what's happened with robotics engineering, well known as mechatronics. Mechatronics, it's actually the mix of electronic field, mechanical field, software field, artificial intelligence field, control field. Well, put it all together, you can make robots, right? And that's provide um, such a tremendous potential to what we was able to do before in those just individual engineering skills. Well, here is the same principle. When you put different expertise together, you get a much more powerful solution. So when you look at the Industrial Revolution, is that what we think in the first place is the connectivity of machinery all together so they can understand what the machineries that have done the job before it did, what the machinery that did the job would do the job after it uh, is in a certain state. So all those information and connectivity is useful in a local point of view where you can look at your node surrounding your working environment and adapt to it accordingly, as well as in a general global point of view where you get all those data harvested at all those nodes where it can be stored to a database and later on or in real time being able to be extracted and using data mining process, and you can add adaptive rules, system expert, and other artificial intelligence process to it. But altogether, you can extract information like throughput time, like there have been more rejects than usual to a certain part of the process of the manufacturing, um, for instance. So that's what I mean by connectivity for the fourth industrial revolution, and it's really what built it, and internet is the conduct for this connectivity. So let's look a bit about the previous industrial revolution. When we look at what's have happened in the past, we can understand a bit better what's potentially coming. So the first industrial revolution started around 1780 with the development of steam engine. As you will see, there is a direct connection between the trigger tipping point of an industrial revolution and the maturity and emergence of a technology that have such a consequence over so many fields that it become revolutionary. So that's what happened with steam engine. Steam engine was able to develop motion, was able to make repetitive, linear, and rotative behavior using fossil fuel such as coal and wood. And thus, in that time, in 1780, where there was much more a society of agrarial, where the agriculture was predominant as an industry in general. Most of the product was handcrafted, done with hard labor, was expensive because it was taking a lot of time to be done, and quite individualized. A lot of work was done by the horses, which was requiring a lot of maintenance, was animals. So as humans as well, we have need to rest and to have we not will behave necessarily in a repetitive way, the exact same way every time. And you see that's what steam engine gave, plus the extra power that using the burning energy to boil water, which creates steam and push through pressure system, created the first automation of motion. And from that on, where the city started to become bigger and bigger, where you would have a lot of labor, class that didn't exist before and was kind of created through the first industrial revolution to maintain this machinery and so forth. So this was really good for a kind of a repetitive task where there just was one flow up and down, such as the textile industry, which was one of the great revolution to have much cheaper clothes, much quicker done, with better quality, and so forth. And that led us to the second industrial revolution that happened about a century later, in 1870. At that time, the new technology emerging was electricity, and a byproduct of electricity is electrical motors. The electrical motors allow, in a much more condensed fashion, to imitate the power motion of the steam engine. But you don't need an oven anymore. You don't need a boiler. And you don't need pipes all around. You need some electrical wires that are easy to conduct to put around, and the size of the motor as well was so much more compact. This allowed to really start the mass production, where assembly lines and development of uh, large quantity of products have been possible. As we will see then, that's as well will um, collide with loss of other jobs and more creation of different one. As in the steam power, where there is horse and different work such as blacksmiths and things like that are starting to get endangered and disappeared for the sake of other jobs, and service society was starting to be created, where there's this third sector of economy that we call the services job started to emerge. And the same thing with electrical power started to grow there with the change of society due to electricity. Now, the third industrial revolution, where we reaching the end of it, is computers. That's what actually was allowed to provide to motors brain, if you prefer, so that we not just activated on and off, on and off, on and off, but rather will be able to take feedback from sensors and give a much more complex behavior, such as controlling in a much more fine way what it manipulates and how it goes, and that's where robotics emerged and was possible to be developed at that stage. And that was around a century later again, 1970, where computer was already hitting the industry. And that's what we know best nowadays, right? Something changed. Internet became more and more something, and internet allowed all the different fields where you have technology involved and expertise of different things to be connected together, put down the barrier of the world where instantaneity became the rule. And that have speed up actually the transition to a fourth industrial revolution, where the connectivity of the machine allow to reach production of custom products to the cost of a mass production product. And without even the intervention of a human, you can see that you order your product on internet and that you select all the different specific options that you want, making it more and more unique products, and if you can imagine that you can put your photos that you've chosen on it, make it fully unique, right? And so you send that, and the manufacturing place where which receive your order basically look at all the options, convert it to machine code, and produce your system, package it, and it's ready to go. This changed the game of our standard of living, what a product is, how we use a product, what type of product we can create. It's going as well. Uh, Not only that's happening because this is just the advanced automation part of it, but these are as well materials area where there's so many new materials coming up, and 3D printing. These like information that you can get from just biomedicals and DNA. There's so much interaction between all those fields that the fourth industrial revolution is becoming a connection of all the skills together. It's the same thing like oh now universities, manufacturers, service providers, and other um, type of industries are starting to work all together so that they are getting better products, more professionally made with a much more efficient process. And so, if you look at the global growth of human development, um, where human is prospering the most, you can see that it's highlighted by Europe, America, Canada, Australia, Chile, and Argentina. But when you look at who is do the production for this minority, you can see that Argentina seems to work well for itself, but most of the other countries all concentrated about China and few other countries here and there, but that's where the industrial production growth rate is going. Something that can change though with industrial 4.0 is the fact that you can produce without taking into account the cost of labor, as the labor will be virtually in existence anymore and will be replaced by a different type of also job. If we look at Australia in population, we can see that Queensland is currently in high growth, and we are expected to increase our population by 20% really soon, right? So this tells us that we are having a much more favorable area and prospects to job in Queensland. But there will be a lot of people where we need to find jobs for. So what's going to happen to the jobs? Well, there's a different aspect to it. If you look on this chart, the what have happened between 1840 and 2010 about the trend around jobs. Here you can see that in 1840 jobs was primarily in agriculture, right? And this declined drastically and very quickly, constantly over the years, as there was more and more machinery that was put into agriculture work. So the labor um, in agriculture was not required uh, as much. And nowadays, farmer can deal with a very large amount of fields thanks to a lot of machinery, and will be able to even further delegate his works as we get the machinery smart. So basically, humans, workers, get out of the agriculture in the labor force part of it. If you look at the industry, which is the second sector of activity, industry started to grow out in 1840 with the second industrial revolution, first and second, and then at around the time where the second industrial revolution was starting to decline, you can see that after the 1950s, it started to decrease. Industrial labor was not anymore required as machinery was replacing more and more people in there. But what have happened is that all those jobs has been transferred through the third sector of activity, which is services. And over the years, from 1840 to 2010, you can see how large the services industry has become, taking over 80% of the current amount of jobs. That means that pretty much 80% of you in the room would have a service job. Well, this is going to be more and more true, which is going to show that actually agriculture will be next to nothing of the amount of people directly working on it. Industry and manufacturers will actually become more a service company rather than a manufacturing company, where their manufacturing capability, which will be done by the robots totally independently, will be focused towards customers' needs and enhance the needs of the marketing part of it, rather than the production part of it, which is all taken care of and will be totally automatized. So all the effort and more productive effort for the company in a rate of wage to production value to the company will be all toward sales and services. Okay, now that's another look at how much net employment will look by job family around between 2015 and 2020. And you can see that here again, office and administration is a predominant part of it, followed by manufacturing and production, construction and extraction, and then art, design, entertainment, sport and media, because there will be more and more free time, and it's actually not that bad there for those industry. They're going to grow as people going to look more and more for recreational products, which is conveyed for us through art, music, and so forth, video games and things like that. So, and you can see as well that there is a combination of art and technology that is more and more present and have been for quite a while now. So it seemed like when you automatize, it's equivalent to prosperity, right? When you automatize, what matters then for manufacturer is the initial setting up cost. Once that's done, you don't have to worry anymore about the labor cost per product, as there is no labor anymore related to product it. Probably there is some labor in the service part of it to make the effort to sell the um, product, but that's going in different categories, and the production cost due to labor. That's where China became the industry of the world with low salary and was able to develop really cheap products for the world um, by having a really highly competitive wage advantage. But if you remove that, then that means that what's left is just the installation cost. And even if it's cheaper to install it in China, after all, if you install it in Australia, for instance, then it doesn't matter what is initial cost is, because it will be easily recouped by the amount of sales of tens of thousands of products, where then you become competitive worldwide. You are able to recruit more people because you have a much bigger market. And so then as well you are saving a lot of cost because you are producing right where your clientele is. So there is then a notion of no matter where you are, the products will be equally expensive due to the fact that it will just depend about the cost of the sales and service rather than the cost of the product itself, which will be identical around the world thanks to the automation. So do we have an example of that? Yes, we do. Germany already have done the steps, and it has been like a 20 years efforts where they have constantly invest in new technology to reach Industry 4.0, which is a really strong program by the government of Germany. And here is an example of the consequence of it when you look at what happened with growth of robots in the automotive industry, which is highly criticized by robots stealing labor job and things like that. But in fact, when you look at the numbers there, you can see that the increase of robots in German automotive sectors is related to the increase of humans in the automotive sectors. And actually, you can see that actually the initial growth of the sector in automotive of robots did correlate more or less with human growth in this industry, but then the growth of robotics was slower, but the growth of human jobs in this sector was increasing. So it's really show you there like this misconception of robots steal our job, which is totally the wrong way around. Actually, robots create us jobs. The thing is, they're not the same jobs that we was used to in the past, and it require the society to adapt and to consider the different training option that can be suitable to the person. And there's a lot of things that are no-brainer. It doesn't have to be a high scientific person job. And so here we are. We can see Germany made it, and recently they reached full employment, are world wide competitive with their products that keep their well-renowned quality as well, which make all the difference. And they reached all that thanks to automation and applying the principle of Industry 4.0. So what's next? Well, artificial intelligence is on the rise. You can see a lot of progress that have happened in artificial intelligence, such as DeepMind, developed by Google, which have recently beat the best player of Go, which was really a big milestone, which have already beaten chess player Kasparov, but beating the best player of Go was again another milestone to prove the capability of artificial intelligence. Another fact that I can tell you is how artificial intelligence was able to demonstrate the experiment of Nobel Prize to detect the Einstein boson, which took years for humans to um, do so, and the artificial intelligence without any knowledge prior that about how to do the experiment, but just knowing the aim of the experiment, did it in less than an hour. So really, really amazing. And what that tells us is that we're reaching time where of maturity where can show robots or any type of task what need to be done without having to insert the rules to it. The system will process how it works, get positive and negative inputs, and will determine actually what need to be done to win the game. And winning the game maybe just to sort out some paper or to get a positive test in an assembly of a product, for instance. And once that is completed, then the person or let's say, I mean, that's a lapsus. The robots will be able to apply the task, such as if you would have trained a person to do so. And that shows how cognitive sense and how we can interpret learning through observation provide such a powerful tool to have an artificial intelligence system which doesn't have to be specialize in a task while observing a certain job, can learn it and get better at it and simulate it in himself to do it so many times internally that it became instantaneously an expert at it. When you look at the manufacturing chain line, what that gives us is the robots are communicating with each other. The products communicate with the robots and the assembly line, telling what process have been done and get an ID straight away modified as the process is completed, and provide basically a real-time information about how well the product is constructed and how fast, and give any stats that really you want, while being a really adaptive chain line where according to the different type of product, the robots would have a different type of attitudes and can be used for different uh, type of job. So I hope that you have enjoyed this presentation about the industrial revolution that we are looking at crossing right now. You can look at all the technology available. It's not something of the future. It's already something you can buy off the shelf nowadays.